So we have trig functions, for example, sine of x and cosine of x, right? And then remember, in right angle trigonometry, sine would mean, let me just use x instead of theta, opposite over hypotenuse, and cosine would mean adjacent over hypotenuse. And we also know that sine is v over r and cosine is u over r when we look at circles, when we look at the entire coordinate plane with any angle. Now what we're going to do is we're going to introduce two new functions, sine inverse and cosine inverse. And what they do is they kind of do the opposite thing. So instead of saying, okay, sine of 45 degrees, right? What is opposite over hypotenuse for 45 degrees? What's v over r of 45 degrees? We're asking what angle theta gives you the sine or cosine value x. So in some sense, we're kind of, instead of saying, okay, here's an angle, what's the ratio? Like, whether it's v over r, u over r, or opposite adjacent over hypotenuse. We are asking, here's a ratio, here's a number. Can you give me an angle, what angle theta, that gives you the sine or cosine? So for example, let's say, what is sine inverse of square root of 2 over 2? This means what angle theta gives you sine of theta equals root 2 over 2. We're asking the opposite question that sine or cosine asks. And well, okay, it's kind of like, right, it's the opposite, but how do you go about it? Well, there are several ways of thinking about it. For this one, if you remember, sine of 45 degrees is root 2 over 2. This is one of the special angles. So sine inverse of root 2 over 2 is 45 degrees. And so remember that for inverse functions, the input and output are kind of switch. So if you look at just these two things, the answer, or the original question, and like what we use to answer it, these are opposites. Sine of 45 is root 2 over 2, so sine inverse of root 2 over 2 is 45. Problem is, this is usually really hard to figure out for an angle that isn't 45 degrees, or sine or cosine that isn't root 2 over 2, or 1/2 or root 3 over 2, or any one of those special angles that we all know and love. What if the answer was like 15.7 degrees? I don't know. So what we really end up doing is we really end up needing a calculator for all of this. In the old days, we look it up in a table or use a magical thing that isn't a calculator, but now we have calculators or computers, so we can use those really easily. On your calculator, usually there's a sine button and there's a cosine button. And then on the top of those buttons, or on the bottom, is a sine inverse or cosine inverse. And so what that means is that it's kind of like a computer keyboard. If you press shift or whatever, and then press a key, and then or you hold shift and you press a key, you get the thing. You get like a slightly different thing. Here, if you want the sine inverse that's up here, or the cosine inverse that's up here, you've got to press either shift, or on some graphing calculator is called second. You've got to press one of these buttons first, and then press sine or cosine. And that would give you sine inverse or cosine inverse. So instead of typing in 45 and then pressing sine, you would type in root 2 divided by 2, which would be like 0.7 something, and then you press shift or second and the sine button, and they'll give you 45 degrees. So this will be, kind of the thing that you need to do, because you really don't know all these infinitely many values by heart. And it's cool. That's why we have calculators. That's why we have like things. Okay. one other concern. You should know that, say, for example, if I'm on a unit circle, there, and I wanted, say, a cosine of 0.8. So this unit circle has a radius of 1. So this is my cosine. I want a cosine of 0.8. Well, there are definitely two angles, one here and one here, that have a cosine of 0.8. The unit circle is not like a function by any means. And in fact, to make it worse, you can add 360 to any of these angles, or 720 or whatever, and get an angle with the same cosine of 0.8. That's kind of crazy. In fact, every sine or cosine value has infinitely many angles, many theta associated with it. That's not helpful. It's like, in fact, even it doesn't just fail to be a function, it fails to be a function infinitely. So what we actually end up doing is we restrict the domain. You've seen that in a function like x squared, you can only look at the positive square roots. You can't look at the negative square roots if you want an inverse function, as opposed to an inverse thing, or technically inverse relation. So what we end up doing with sine and cosine values is we actually look at the unit circle. We go back to the unit circle, and we go, alright, this is the cosine axis, and this is the sine axis. For sine, we want to go from, let me use blue for sine. We want to go from negative 1 to positive 1 on this axis, right? This is the range of sine. And so, what are the range of angles that give us that? Well, there's this angle, which is minus 90 degrees, all the way to this angle, which is positive 90 degrees. So, essentially what we say is that when we look at sine inverse, we're really only looking at angles between minus 90 and 90, because the sweep from here to here automatically gives us all the sine values that we care about. We don't really care about any of the other sine values. And similarly with cosine, let me remove this. Undo one more time. For cosine, we want to go from minus 1 to 1, from here to here. And so that's from 0 degrees all the way up to 180 degrees. So that's really the only angles we care about, because those would give us all the whole range, pun intended, of cosine that we need. And so we don't really care about the other ones, because we can just say, well, yeah, like we can figure that out by adding 360 or 180 or some crazy magical thing to figure it out. We'll deal with that later. The important thing is that for sine inverse of x, we only look at angles between negative 90 degrees and positive 90 degrees. So the range of sine inverse is from negative 90 to positive 90 degrees. And for cosine inverse, we look at 0 degrees to 180 degrees. These are, when I ask you, okay, what angle has a cosine of 0.8, you can be like, oh, I'm gonna say, like 5,278,000,000 blah 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 degrees, you can't be like a smart ass like that, because we're automatically assuming 0 to 180 degrees. That means there's only gonna be one unique answer. So that's why we call these inverse functions, because we just say there are infinitely many answers, but we're only going to look at the ones that, you know, are the simplest ones. Like 5 billion degrees, that's kind of stupid. But, you know, 20 degrees, that's cool. Like, that's something we can visualize. Why go to 5 billion when you can just look at 20? 20 is nice. So, when you use your calculator, the calculator also uses these ranges. So it's good to be kind of standardized, so we all know what we're talking about.